The moon is our cosmic neighbor, but Mars is considered our sister planet. It's a mysterious red world that has fascinated humanity for generations. While the space race was once dominated by superpower rivalry, today every nation dreams of being the first to set foot on the red planet. But what would such a journey actually look like? We're not talking about an instant jump or a spectacular teleportation, but a long, dangerous, and meticulously planned voyage. Here's how this unprecedented cosmic adventure will unfold, step by step, and why every phase is crucial to turning the Martian dream into reality. Why Mars? Why do we even want to go there? The red planet is the most habitable neighbor to Earth and has fascinated us for generations. It has a day almost as long as Earth's, lower gravity so you can lift heavy objects and jump more easily, and an atmosphere that, although thin, might allow plants to grow with some adjustments. Humanity doesn't just want to explore it. We want to build a self-sufficient city there. Millions of tons of materials and equipment, thousands of launches, and decades of effort could turn Mars into a second home. NASA paved the way with its rovers from Mariner 4, which in 1965 sent the first images of a barren Mars, to Opportunity, which traveled 45 kilometers across the planet and transmitted data for 14 years. The American agency turned Martian exploration into a story of endurance and discovery. Mariner 9 revealed massive canyons and giant volcanoes, while the Phoenix probe confirmed the existence of ice beneath the surface. Constraints. But traveling to Mars isn't just about rockets and rovers, it's about real people with real limits. At over 200 million kilometers away, astronauts will be exposed for months to intense radiation without the protection of Earth's magnetic field. NASA studies have shown how space can alter gene expression, DNA structure, and even the immune system. Psychologically, it's total isolation, delayed communication, and a spacecraft that becomes the crew's only home for nearly 2 years. Simulated experiments like Mars 500 have tested mental endurance under extreme conditions. No natural light, team tension, disrupted sleep cycles. Beyond the human factor, technology must perform flawlessly. Everything from food to fuel, water, oxygen, and electricity must be planned down to the smallest detail. You can't order spare parts from Earth. It would take nearly a year for them to arrive. Rockets need to carry tens of tons of equipment, and the Martian habitat must sustain life in a hostile atmosphere, one without oxygen, filled with fine dust that can clog filters, ventilation systems, and solar panels. Dust storms can last for months, and current spacesuits, heavy and cumbersome, will have to be redesigned to withstand daily life in such harsh conditions. Phase 1. Pre-launch preparations. Before heading to Mars, we need to ensure humans can survive the journey. It's not like boarding a plane. In this first phase, the United States, alongside other countries and private companies, is developing technologies to overcome all the physical and psychological challenges mentioned earlier. Rockets must be larger and more powerful, spacecraft safer, and every gram of water, oxygen, and fuel precisely calculated. Currently, advanced propulsion systems capable of sustaining a 2-year journey are in development, along with super heavy launch rockets. SpaceX is building Starship, NASA is working on SLS and the Orion capsule, while Boeing and Lockheed Martin are also in the race. The message is clear. The mission to Mars begins on Earth, with the most advanced technologies ever created. Astronauts won't travel empty-handed. They'll bring essential supplies, oxygen, water, food, and radiation protection. NASA is developing intelligent systems that can transform local resources, like MOXIE, which produces oxygen, and recycling systems that recover water from condensation or even urine. Just as on the International Space Station, food won't come only in packets. Plants will be grown on board in portable mini-greenhouses to ensure survival on the long journey. NASA is also designing futuristic navigation systems, inflatable rocket air to cushion the descent of heavy spacecraft, new generation spacesuits that are lightweight, flexible, and durable, personal homes in the cosmic vacuum, and mobile habitats that can serve as both laboratories and temporary shelters en route to Mars. On board, astronauts will have surface energy generation systems that can function even in deep space, and laser-based communications, capable of transmitting high-speed data to Earth including real-time images and video. In short, everything is tested and perfected before launch. Rockets, spacecraft, life support systems, and even astronaut routines. This means training, simulation missions, technologies for independent power, and habitats that function like space homes. Nothing is left to chance. Phase 2, launch. The moment of launch is when everything becomes real. After years of planning, testing, and intense technological development, launching a crewed mission to Mars will be one of humanity's most spectacular and significant achievements. Astronauts will be strapped into specialized cabins as the engines break the silence of the launch pad. Once the spacecraft escapes Earth's gravitational pull, the true interplanetary adventure begins. But a crucial question arises. How long will the journey take? The distance between Earth and Mars varies enormously, from 56 to 401 million kilometers, which affects travel time. With current technology, the trip takes about 9 months, and a round-trip mission could last up to 3 years. It all depends on the launch window, a period of orbital alignment that occurs every 26 months, and on trajectory, energy, and fuel. In short, missions must be planned mathematically. The good news is that technology is evolving rapidly and will soon reduce travel time significantly. Research is already underway on photonic propulsion systems like Project Deep In, which could send robotic ships to Mars in just 3 days using powerful lasers. For now, systems like SLS promise to shorten human missions as well. Phase 3, the journey. After leaving Earth's orbit and separating from the launch vehicle, the interplanetary cruise phase begins. Months spent aboard a small floating world with one destination, the Red Planet. During this time, engineers on Earth continuously monitor the spacecraft, check systems, perform trajectory corrections, and simulate landing scenarios. Meanwhile, astronauts live in zero gravity, exercise daily, conduct scientific experiments, and practice descent procedures. Solar panels must be constantly oriented toward the sun, antennas toward Earth, and the spacecraft kept on a precise course between 2 constantly moving planets. But what is it actually like to live en route to Mars? Imagine a futuristic minimalist home. 4 astronauts living for months in a confined space, equipped with everything necessary. NASA is considering several propulsion options, including nuclear, electric, nuclear thermal, hybrid solar chemical. Each offers advantages in efficiency, speed, and weight. During the trip, the crew's mental health is as vital as their fuel. They'll be completely isolated from the rest of humanity. No windows, no fresh air, aboard a ship traveling up to 2 billion kilometers in total. The mission must balance routine with adaptability. There will be moments of relaxation, celebration, and communication with loved ones back home, as well as emergency drills. Every minute will matter, whether maintaining trajectory or preparing for atmospheric entry. Phase 4, landing. After months of space travel, the spacecraft begins its approach phase, about 2 months before reaching Mars. During this period, engineers on Earth prepare for orbital insertion, a critical moment when the spacecraft's engines fire to slow it down and establish orbit around the planet. Next comes partial descent into Mars's thin atmosphere using a technique called aerobraking, essentially braking with air like a leaf gliding down. But the most intense stage begins now, the final descent and landing itself. The process, called EDL, entry, descent, and landing, is nicknamed by NASA engineers the 7 minutes of terror. Everything must work perfectly, with no real-time human intervention. Parachutes slow the initial descent, but for heavy crewed spacecraft, supersonic, retropropulsion, braking with rockets during descent will be necessary. For the Perseverance rover, NASA used a sky crane that lowered the rover by cables in the final seconds, avoiding direct impact. Visual navigation systems will automatically recognize terrain features to avoid rocks, craters, or dunes. Landing is, in fact, the key to the mission's success. No matter how powerful the rocket or advanced the spacecraft, if you don't land safely, everything is lost. That's why NASA constantly tests new methods, from the airbags used by Spirit and Opportunity to advanced terrain recognition, maneuvers for Curiosity and Perseverance. Every centimeter, every decision, every descent algorithm is designed to ensure the safety of a landing that, in a crewed mission, would become humanity's greatest achievement beyond Earth. The landing site isn't chosen randomly. It must be both safe and rich in scientific potential to justify the risk. So the journey to Mars won't be easy, and it certainly won't happen overnight. From complex preparations on Earth to launch, cruise, and landing, every phase is essential and must be flawlessly executed. Every step matters. The mission's success will depend on countless decisions, technologies, and people working with precision down to the millimeter and the second. Mars isn't just a destination. It's the ultimate test of our intelligence, courage, and cooperation.